looks really gross, but think it through with me, okay? Now, you can clearly see it doesn't exist at x equals 0, right? Because you're going to have division by 0, so it breaks, okay? But x is not simply the denominator, so you're not going to get a vertical asymptote. In fact, this denominator here can never equal 0, right? Because if it was to equal 0, you'd have this, right, being equal to 0. So you have 2 to the power of minus 1, right? So then you're like, hold on a second, I need to come up with some power, and I raise 2 to that power, I get a negative number. Now if you remember from logs, no such number exists, okay? So therefore, this denominator will never equal 0. So this whole function will not have a vertical asymptote. So what does it look like? Alright, now this is a really good example of thinking about the 2 kinds of limits that we were looking at before, from above and from below. Okay, so think with me for a minute.
Don't we know straight away that x can't be equal to 0?
Yes, we do, but I still don't know what it's actually doing there, right? I don't have a vertical asymptote, I've got something else. The question is, what is it? So, I want us to think about, what's this thing doing as I approach 0 from the right-hand side? Okay, so, well, really, y. Okay, what's it doing, right? Well, as x approaches 0 from the right-hand side, what kind of numbers am I thinking of? Okay, from the right-hand side, I'm actually getting closer and closer, this is a limit, to 0, right? So I'm actually thinking of very small numbers that are positive. They're the numbers on the right-hand side. Okay, so numbers like, say, oh, I don't know, put in another color. Numbers like, say, 0.1 and 0.01 and 0.001. So I'm approaching what's happening towards the origin, but from this side. Okay, so think with me. Okay, what am I going to get as I put numbers like that in here? 0.1. Let's just do 0.1. Okay, 2 to the power of 0.1. Well, sorry, 1 over 0.1. Okay. Okay, so let's think about this. I'm just thinking about this one little component here. Okay, this is going to be 2 to the power of 1 over 0.1, right? Which is actually 2 to the power of 10. Okay, which is 1024.
Yeah, that's what I said.
Okay, so
I said
1024.
512 twice.
Right, good save. So on the bottom here, I've got 1025. Okay, 1 over. Now, okay, what kind of number is that? It's very, very, very small, right? What's going to happen as I approach this? Yeah, that's right. This is going to be 2 to the power of 100, okay, which I don't know what that is, but it'll be a very large number, okay? So this limit is equal to 0, okay? Are you content with that? All right, let's think about what happens on the other side. Okay, so I'm coming from the left of y. So a value like, say, minus 0.1. Minus 0.1. What would that mean up here? Well, it'd be 2 to the power of 1 over minus 0.1. Right? Which is 2 to the power of minus 10. What kind of number is that?
1 over 1.
So a very, very small one, right? So this is 1 over 1024. And then the next one will be, this is minus 0.01. As I'm getting closer to 0, but from that side, okay, it's going to be 2 to the power of, well, 1 over 2 to the power of 100. Okay? So in the first place, as I went from the right-hand side, the whole denominator was skyrocketing. So therefore the whole thing got really, really small, right? Because it's got a big denominator. But here, what's happening? When I'm approaching from the other side, this thing, this 2 to the power of, it becomes insignificant. So if it becomes insignificant, what am I left with? 1. Just 1. Okay, so what's this thing look like? As I'm approaching from the right, I said we were getting closer to 0. Okay? And it's going to be doing something like this. It's going to be coming from above. Okay? When I came from the left, I was approaching 1, right? Something like that. So what happens on the ends? What happens on the ends? How would you work it out? we're getting some asymptotic behavior, right? But it's not vertical. What kind of asymptote do you expect?
Oh, so it's like.
You guys know how to find asymptotes of rational functions. This is not a rational function, right? Isn't it? Of sorts, okay? So what's happening as I put enormous values of x in, okay? When x is, say, 1,000,000, okay? This will be 2 to the power of 1 on 1,000,000. And then 2 to the power of 1 on 100,000,000. What's happening to it? It's getting closer to 2 to the power of 0, right? Isn't it? That's what it's approaching. So if this is 2 to the power of 0, that's 1. So I've got 1 over 1 plus 1, which is 2. And you can go and verify, the same thing will be happening on the left-hand side. So if I have 0 here, I've got 1 here. You have a horizontal asymptote of y equals a half. Okay? So the kind of behavior you've got looks like this. That's messed up, okay? So what was my point, okay? This function is clearly not continuous, right? But it has no vertical asymptotes. There's a domain issue. What is it equal to here? It doesn't equal anything because you can't substitute x equals 0 in. It breaks it, right? So therefore, doesn't exist here, doesn't exist there. Both open.
I like this graph.
Okay.
It's like a weird snake.
Okay. So, sorry, that was a bit longer than I intended, but that's okay. It's still to illustrate the point that discontinuous functions, they come in all shapes and sizes. Okay?